One of the most intriguing and strange concepts in physics is the notion of time. After all, time is, in the literal sense, unclear what? There is no definitive physical explanation of what time is. Yet, nevertheless, time in one form or another, for us, as inhabitants of this space, this dimension exists. But what to do when this unclear, strange, and convoluted concept meets an even more unclear, and even more convoluted concept? Yes, we recall gravity, and we remember that time is interconnected with gravity. Moreover, we remember that often various games related to the theory of relativity also affect time. Therefore, today we are discussing how gravity can affect time and how that very gravitational time dilation occurs, which you have surely heard about many times, but didn't understand how to approach it. As before, my name is Yuri Trifonov, and today we have a rather interesting, intriguing, and even important topic for understanding. So subscribe, like, and most importantly, watch the video until the end. I think you have heard many times about the concept of changing the speed of time. You have surely observed this phenomenon in some popular science literature, in science fiction, and many other places. However, you might not know that gravity is involved here as well. The peculiarity of the issue is that when we explain the unknown with the unknown, it becomes even more confusing. In some sense, this is exactly that case. We take the concept of time from physics, which in itself is quite, let's say, convoluted and perhaps even not objective. We take the concept of gravity, which is even more convoluted and even less objective. Although there are some scientific achievements there, but that's a separate topic, and we try to somehow connect it all. As a result, we find that gravity is capable of slowing down time. But how can it do that? Ideally, to discuss such phenomena, it would be very beneficial to somehow learn to describe both gravity and time. But, one way or another, we don't have a single unambiguous definition that fits either gravity or time. Time is some kind of entity that in physics resembles a metric more. Time does not have properties that are characteristic of matter, and time, in the form it exists, cannot be something like a material object. There are many different debates on this matter. There are various concepts, and there are intriguing representations that you might have seen in science fiction movies, where time acts as a material substance. All right, time is more or less understood. Let it be a metric, but a global metric, and we perceive this metric as part of our lives, which in general is inevitable. And what about gravity? And what does gravity have to do with it at all? And our scientific description of gravity is based on Einstein's theory of relativity. And there's no need to write in the comments now, "Oh, look, he also jumped to Einstein," back and forth. I remind you that we are a scientific community, and we don't measure by who aligns with what, but we start from objectivity. And what is objectivity? Objectivity is, for example, the fact that we have GPS navigators which take into account Einstein's time dilation, and therefore we have the right to believe that this logic works in one way or another. In short, it's the distortion of space. I am compelled to once again draw your attention to the very fact of space distortion. I remind you that this distortion is not a physical distortion of space, which resembles the distortion of a sheet on which a watermelon lies. This is the most common misconception. Later on, you will learn that this example, well, let's say, might be a good illustration of the deformation itself, but by no means is it an image of the cause of this deformation. However, what is important to us right now is precisely the deformation of spacetime. In reality, the processes are significantly more complex, and to properly understand these processes, one needs to be very well versed in higher mathematics. Space has a certain mathematical model and a certain structure. Space consists of nothing. Space is a mathematical concept, but in order for us to depict and visualize space, we use these legendary volumetric grids. You have surely seen this, and if you haven't, I will find and show you a picture now. And as long as this grid is straight, all events occur in the manner they are supposed to. But you have surely seen something else as well. You have surely seen that with the appearance of a massive body, this space, time begins to deform, and it doesn't matter for what reason it starts to deform. Because this is a very complex question, about which I think there will be a separate video. What is important is that the metric of space itself, and with it time, changes. This means that in the presence of a massive body, the parameters of space will be different. and what is essentially the slowing down of time. It is very important to understand this in itself. The slowing down of time is only possible in the relativity of measuring this phenomenon. In the frame of reference where time slows down, we will never know it. And I always use Superman as an example for this moment. For instance, as strange as it may sound, in Smallville they always show him running like shh. And for him, time stops around while he runs at his own speed. From his frame of reference, he sees everything happening in such a way that outside everything is very slow. But for him, it's a normal speed. We said that in the space-time speed of light pair, space is necessarily distorted, time is distorted, but the speed of light remains constant. By the way, speaking of which, it suggests itself. The answer to a rather common question about measuring distance in space using light years. You probably all know about this, that everything in space is so long and large that it needs to be measured by means of such strange units. But these strange units appeared not only because we don't have a ruler long enough to measure cosmic distances. These units also appeared because they describe the specifics of light behavior in distorted space-time. When we take that very mathematical model, which has undergone changes in the presence of a massive body, we understand that the guidelines have changed. This would be equivalent to going to a store 1 kilometer away and then the store moved for some reason. And when the store for some reason suddenly moved, we understand that the usual route, which used to take us 5 minutes and required us to walk 1 kilometer, will now take, let's say, 10 kilometers and will require from us, let's say, 40 minutes, any number you choose. The main thing is to understand that the path has changed. And so a light year allows us to account for those very distortions of space-time that occur when a massive body appears there. We remember that space is connected with time. I've already mentioned this, even several times in this video. It is so connected that when the metric of space is distorted, what inevitably happens? The distortion of the time metric. And how can we imagine this for ourselves? Oh my, just like we talked about the store that arrived. You used to walk 1 kilometer to the store, and now you need to walk 5 kilometers to the store. We had a path that light should travel in space. It was 10 centimeters long, but it became 20 centimeters long because a massive object appeared, distorting space-time at this point. And with the increase in distance, the time required to cover this distance also increases. The massive object distorts our imaginary grid, our mathematical model. And we understand that. If previously the particle needed to cover 2 millimeters, now it will cover 4 millimeters. This will require more time. In essence, gravitational time dilation is a distortion of the space-time metric caused by the specifics of the formation of space itself. Or, to put it in more understandable terms and in a more schematic language, speaking in a language you might be more accustomed to, it's like the distortion created by a melon on a sheet. This distortion leads to time starting to flow more slowly, or in some cases beginning to accelerate.